Oh. Yeah, it is. But now I don't have to keep turning back. That's kind of nice. Yeah.
Yeah, I know, we have new scenes working and everything, so just switching it up. All right, today we're just going to just do a couple notes today, and then I'm going to give you some time where you can work on this assignment. That was the page 193. Just remember, 193, if you were gone yesterday, you need graph paper. Does anyone need any? Okay, there you go. Okay, for those later on, I know we did a book check yesterday, so if you didn't have your book, I'll check again today. So page 193, remember, 14 through 17, all you have to do is find slope. I did want to know what type of slope it was, like negative, positive, zero, undefined. You have to tell me the type, and then you just have to find the number. You didn't have to graph it, because you just had to find the rest of them, 18 through the 37. Every one of those terms you have to graph, every single one. That's why I gave you this piece of graph paper that had 12 graphs on it, okay? Because you need 11 of them. So just make sure you are doing that, especially like 18 through 20. You have to graph the points, draw the lines, then you can tell like what type of slope it is, so that when you actually find it using the formula, it actually justifies the picture. Okay? Just make sure that you're being very clear which problem you're working on. Nothing's more frustrating than having somebody just put their name at the top and then there's graphs. No numbers, nothing. I have no idea which problem's which. So just make sure you are numbering as you go through. Okay. When is that assignment due? Right. So just make sure you are working on it. I know it's not difficult. I had some people yesterday that actually got done like throughout the day. It's just that it does take time, especially when you're graphing, you're going slow and all that good stuff. Okay. Today I will give you a little bit of time to work on that, maybe 10, 15 minutes or so. Today we're just going to do a brief introduction to the next section. That's all we're doing. And the good thing is, it's not crazy difficult, the stuff we're going into. It kind of goes hand in hand, which is kind of nice, the stuff we've talked about with what we're going into. All right, so let me throw a graph up here on the board. Okay. That's really good. Today, our goal is to go through linear equations, introduce this, right? We've talked about lines, right? How to graph them, how slope works, how to draw coordinates, and all that good stuff. But what we're doing today is talking about when we have a line, right? When we have a linear equation, when we have a line, there's an actual formula for it. There's like an actual mathematical formula that can actually give you the numbers on the line itself. Okay, so that's what we're going to look at today. Now there's 4 forms. We're going to go through each one today and talk about like the purpose of it. Okay, that's what we're doing today. So it's going to be kind of a light introduction. So that's where my examples will come into play. And then I do want to, if we have a little bit of time, because I don't want to take all the time, if we have some time, I want to talk about these intersections today. Like if we were drawing multiple lines on the same picture, what would they look like? Make sense? Okay, I'll just go with that. All right, so let's start with the first one. First type of form is called point slope. It's called point slope form. Now, I need to raise a hand. How many people have actually seen that formula before? Okay, so a select few of you. All right. So the idea is that on point slope form, this is the form we actually use when you have a graph and you need the formula from it. Okay. So again, purpose of this point slope form. So I think some people tend to forget like what we use it for. This is if you have a graph. You have a graph where you have some data, and what you need is you actually need a formula to represent that. You need a formula to represent it. Does that make sense? Like what we're going to be using it for? So we have the data. So let me give you a graph here. Let's go 2 times 3 and 9 comma 1. All right. So here's my one. Okay, so there's my data. Let me give you the coordinates here. This is 2 comma 3, and this is 9 comma 1. All right, so if you have a personal business and you're plotting like your sales, you're plotting like your profits, and you did for January, you did it for September, and you're looking at maybe how many items are in stock or profits, whatever the numbers represent for you. Okay. We can actually come up with a formula that represents your equation here. Formula. So why that's important? If we have a formula, you can project what will happen later. Okay, that's the idea. You can actually use a formula to get data for whatever purpose you need it for, as long as it sticks with the trend. This is like a linear equation, so it's not going to curve. So it's going to stay with that perfect trend the whole time. Okay, so that's what we're going to be looking at. Okay. All right, so let's get the formula first, and then we can talk about how to use it. So this is point slope form. That's the formula that you're going to need. You'll need this for the test, for this chapter. Like, it's one of those things like you will want to know that. Okay, now let me explain the different parts of this formula. Then we're going to talk about how we can get this data into that so that you know. Okay, so first, the different parts here. Obviously, what do you think M stands for? Slope. That's the slope that we've been finding the last couple days here. So that's kind of easy. We can do that for this picture. We do the same slope formula. Everything is the same. In fact, on this picture, what type of slope do we have? Negative. It's going down. So we know that. So we can eventually find that here in a minute. Now, the other thing. The plane X and Y. The plane ones, not the ones with the little ones next to them, but just the plane X and Y. These are our variables in this problem. These are variables. These are unknowns. We don't know those letters. Now the other 2 letters, the ones with the ones next to them, X1 and the y1, that is a coordinate from the graph. It's your coordinate from your graph or your data. Okay, this coordinate that you're picking for the x1, y1 has to be on your line. So I'm going to put that in quotes. It has to be on the line. I can't say that enough. Some people, like, they don't realize, like, they just pick a random coordinate. Like, oh, I'm going to pick 10, 14. That's not even on my line. 10, 14 is, like, way up there. That's not even on this red line. This coordinate has to be from here. So, typically, I pick one of the ones that they have already shown me. So that's the one that I'll plug in. Okay, do the different parts make sense now? Okay, so let's get some of the data that we need for the actual formula. The first thing I need, obviously, is I need the slope, because that was one of the first things we talked about. How do we find slope for this? What do we need to do? What did we do yesterday? What was on the homework? How do you find slope? Exactly. We subtract the y's, subtract the x's. So my y numbers. Right, if I give these variables, the y numbers are the second number, so the ones on the right, you have to subtract those. So this would be 3 minus 1. Again, you put the y's on the top. And then the bottom numbers are the x's, 2 minus the 9. And what do I get? Is I get 2 over negative 7. That is my slope. And we said it was going to be negative, right? It was going down to the right, so we kind of figured out what that was going to be. Okay. Questions, comments about the slope? That was basically all of your that you had. Okay, the variables, we're not going to change, so they're just x's and y's, so those are fine. These things are going to stay where they're at. They're not going to change. But now the x1, y1, we need to pick one of the coordinates here. I'll let you guys have choice. Which one? 2, 3. Okay, so this is the coordinate you guys picked. This coordinate is going to be my x1, y1. That would be the 2, 3. Okay, that's the one you picked. It has to be on the line. It didn't matter which one. Now what we're going to do is we're going to take our data, plug it in, and now we have a formula for it. So, for instance, if I take my data here and I plug it into that formula, y minus, what was the y1 number that we picked? What was my y1 number down here? 3. So y minus 3 equals, and now I need my slope, that's my m, so that was the negative 2/7, parentheses, x minus, now I need the x1 number. What was my x1 number down here? 2. Boom. There's your equation that represents your data, that represents that formula. So you take your coordinate, you take your slope, you plug it in, done. That's it. So now why that's useful? Why we use equations? I can predict, sales figures or inventory down the road. That type of thing. Because this is representing a line. So let's say on this data, maybe these were the months, right? These were the months. So that was February, this was September, and maybe this is like inventory in your warehouse. So you had 3 items of this, like 3 calculators, and now in September you had 2. You had 1 calculator. So how many will you have in December? So December's down here. It's over here. So obviously by looking at the graph, we can kind of get a sense for where it's going to be. It's going to be really low numbers, but we can plug in numbers. So the idea is that I can use this to predict what will happen later. So if I want to find out what will happen in December, December is my X numbers, right? The months are the X numbers. So the second month or the 9th month, I want to go to the 12th month. So all I need to do is plug a 12 in here. If I plug a 12 in, this will tell me what my Y number is. It will tell me what the inventory is. All I have to do is solve this using basic algebra, right? Just numerical expressions, right? So 12 minus 2, that's 10. I'm going to take 10 times the negative 2/7. And so if I take 10 times the 2/7, it's negative 20 over 7, which is a terrible number. It's almost the number 3. It's not quite. It's 2 point something. And then I'm going to add 3 across, right? So whatever that is, I'm going to add the 3 across. So whatever 20 divided by 7 is, I'll add 3 to it. And this will roughly give me what my number is. That's the idea. Okay, so back, somebody have a calculator or a cell phone or something like that? So take it out. All I need to know, what is what is 20 divided by 7? I just need to know that. You can use anything you want. So 20 divided by 7, you need to know that decimal.
2.857.
Okay, so 2.857. And that's negative, right? Because it's negative 20 divided by 7. And we're going to add that to 3. So we're roughly, so if we take 3 and we subtract 2.87, what do you get? 0 point something. 3 minus 2.8. 143. Yeah, there you go. So maybe this is an inventory. So maybe you don't have one inventory, you're down to 0. Hypothetically, there's 0. That's the idea. So you might need to buy more. Now, why is this useful? I could have put any month in here. It didn't matter I put December in there. I could put maybe 3 years down the road, so I can see where we're going to be at. That's the type of thing. Like, you can use these to predict future numbers as long as the trend stays the same. Okay, any questions with why we use equations, what we use them for, how we get them? Now, let's see, like tomorrow, we'll practice this like more and more and more, so that you get good at this, so you know kind of what you're doing. So this is the first type. This one for me is the most important for like a pre-calc class, because pre-calc we have crazy equations going on. We have graphs, and we're trying to find equations for them. This is the easiest one. You take data. You come up with an equation for it. It's fast. You just need coordinate and slope. Now, the other ones have their own purposes. So, like, one of the ones that you guys probably know the most is probably SlopeIntercept form. That's the one that most people know from, like, an Algebra 1 class. And this would be probably my last one we talk about today. Does anyone give you some time we can actually work? So SlopeIntercept form. All right, this form is really good if you have an equation, so you have the actual formula. And what we need on this one is we need to graph it. So this formula is the preferred one. If I give you the formula, you can go directly to the graph right away. Like first step, start drawing it automatically. That's what we use this form for. Okay, now I want to give you the equation for it. So again, we don't have the graph now. We have a blank graph, and I want to put whatever equation I have into this box here. All right, so here it is. There's the equation. Now, how many people have seen that formula before from algebra? Yeah. It's probably like the most important one that they talk about in algebra 1 all the time. Okay, because it's easy to draw it, right? What these stand for, right? Well, what do you think M stands for? Slope. So that's pretty easy. Slope, rise over run. Okay, so that's kind of easy. Once we have that, I can start drawing kind of the general trend where the line is going. The B number, the B on this formula right here, that is your y-intercept number. That's why they call this slope-intercept. Now, what a y-intercept is, because some people don't understand what that is. This is just a number, like a negative or positive number. It could be anything you want. It could be a decimal. It's where your line crosses the y-axis. That's what they call it. Okay, so like for instance, this is your y-axis. So whatever that B number is, that's where we're going to hit. So we could have positive numbers, we could have zero, we could have negative numbers, it could be decimals. It really doesn't matter. So that's your y-intercept number. And then the other two variables, the x and y, are just variables. So the plain x and y are their variables. So we could also use this equation to predict future things. Okay, so here's the thing. I want to know a random slope. So try not to give me like undefined, because I don't like that type of slope. So give me a random slope. A random number could be, it has to be a fraction, right? So give me a number. 5/3. Okay, so y equals 5/3x. Now, I need a random b number. It could be positive, negative, it could be a whole number, a decimal, a fraction. Say again? 5 positive 5? Okay, alright. So now, what this is, once we have this formula, I can go right to the graph. Because I know where to start, my y-intercept number, that's where I start. And then I just use the slope, and I can find all the rest of the coordinates and draw the line. Right, so what is my y-intercept on this particular formula? 5, right? That's the b number in the back. So that's where I'm going to cross the y-axis. So I'm going to have a dot on the y-axis at positive 5. 1, 2, 3, 4, 5. So this is where the first dot is. Okay, so that's the y-intercept. So where it's crossing the y-intercept. Then I just use my slope, and I can draw the next couple dots. So my slope here, this is 5/3. That means I'm rising 5, running 3. And it's positive, so I know I'm going up that way. So rise 5, 1, 2, 3, 4, 5, and then run 3. And I always go to the right. 1, 2, 3. And I can do it again, rise 5, run 3, and we can draw the line. So here's the graph for my actual equation. There you go. See how easy that was? Like, it's super easy if you have that form to go immediately to a graph and actually get like a visual representation of it. And now I can use that equation. I can predict the future. Like what will happen in the 12th month of the year. Well, the 12th month would be down this way, and I can figure out where the inventory is. So it's way up. Okay, questions, comments on the two forms. Now, the good news is, because that's where I'm going to stop today, these are your basic ones we use all the time. They're the go-to forms. The other two that we're going to talk about tomorrow, they're kind of like rare cases. We don't use them a lot for this class. You'll see like this, the third one, we'll see it a lot in Algebra 2. The fourth one we use in general, or in pre-calc a lot. So, okay, questions, comments about what we did today, like the intro? Okay, the rest of the time is yours. You have about 12, 13 minutes. You can work on your page 193. Remember, you have to graph all of them except for the first 3 or 4. 14 through 17 you don't have to graph. The rest of them you do. If you need graph paper, don't be afraid. If you need to go borrow a book, that's fine. I need a book check. I'm going to call on people I haven't checked yet. If you have your book, I'm going to check your number. That's all I need to see. So. What do you already? Alright. Let's see. Trent is not here today. Yes. Let's see. Mr. Childress, what do you got for a book?
I don't have my book with me.
And you know your books. You go to the bathroom.
You go to the bathroom.
Inside jokes. Safety.
No, it's just not. So might be
You go to the bathroom. Well, that's nice. Yes. Or for you guys don't really get that mix. Yeah, because that'll make a difference, but she's big back. All right. Yeah, we'll be in the high school.